Okay, we're going to fill in the last 3 pages of our ISN. When a vector is a quantity that has both magnitude, please, or length, and direction. For example, the speed and direction of an airplane can be represented by a vector like 300 miles per hour, 20 degrees north of east. Let's see what that would look like. If you thought about north, south, east, and west, what would this mean? 20 degrees north of east. So you're to the north of the east. So you're north of the east line. So that would put you going that way. And it would be 20 degrees, and that is to the north of east. And the vector would actually be the 300 miles an hour. The magnitude of a vector is the length of we're going to go over more of those later on. Okay, the magnitude of a vector is the length of the vector from its initial point to its terminal point. So on this point A right here, that's your initial point. It's where the vector's starting. And then the tip of it, where the little arrow is, that is the terminal point. Vectors can be represented as directed line segments. The vector shown, which can be called vector AB or vector V, has an initial point at A and a terminal point at B. When placed on the coordinate plane, a vector is in standard form when its initial point is at the origin. So this one is a standard form vector. That one is in standard form. Now, I already talked about that. So now the blank of a vector is described in terms of horizontal change and vertical change. That is called component form. The component form of a vector is described in terms of its horizontal change x and its vertical change y from its initial point to its terminal point. So this is the horizontal change or the change in x, and this is the vertical change or the change in y. You've seen maybe in science the use of delta to mean change. That's a delta. Delta y means change in y. The component form is x and y. That right here is the component form. Okay. From here to here. That's because this one's in standard position with its initial point at 0. So if your initial point is not 0, then we have to do the following. Component form of a vector, you subtract the x's, which is the change in x, and you subtract the y's, which is the change in y. So we're going to write the component form for vector CD. Notice that it doesn't go to the origin. It's just starting at 0, -1 and ending at 4, 1. So the points 0, -1, that's your x1, y1. And the point D is your x2, y2, because that's where the arrow is, or the tip of the vector. To do component form, you subtract your x's and y's, but you start with the tip. So this would be 4 minus 0 for your change in your x, and 1 minus -1 for your change in your y. So what we get from that is 4, 2. Because 1 minus -1 ends up being 1 plus 1. And you could go over and look at the counting on this. If you count it over, 1, 2, 3, 4, and then up 2. Did we get 4, 2? Yes. Another way to look at it. Next, we're going to write the component form for PQ. And I want to check if I've got, yeah. Okay, the component form for PQ, I guess I will do that right here. You've got P is your initial point. So this is your x1, y1. I guess I'll write those down here. P is at -1, 3. So that's x1, y1. And Q is at -3, -1. So that's your x2, y2. The component form for P vector PQ then would be -3 minus -1 and -1 minus 3. Simplified gives us -3 plus 1, which is -2, and -1 minus 3 is -4. That is the component form for PQ. Now, what does the component form do for you? Well, it just shows you the change in your x and the change in your y. You could plot it from the origin, and then you would be able to see it would look a little bit differently, or just be a relocation of the same length vector. Now, if you wanted to count, can you see that if you went from P to Q, you would have gone left 2, down 1, 2, 3, 4. Count it on there as well, if it's graphed. Okay, you can use the distance formula or Pythagorean theorem to find the magnitude of a vector. The direction of a vector is the angle that is formed with the positive x-axis and any other horizontal line. That one's found by doing the inverse tangent. All right, let me show you what they're talking about here. So if you drop a vertical right here, this would be your y, or your change in y, and going this way would be your x value, or your change in x. I would like you to change that x degrees to a theta. So I'd rather you have something besides an x there. So I'm going to make a little theta, which is a Greek symbol, and say theta degrees. Okay, and it says right here, theta equals the inverse tangent of y over x. So all you're doing is finding this angle right here, that's your theta. The magnitude we find with Pythagorean theorem. So let's do an example. Oops, I forgot to erase this. All right, here's on the next page, we'll have an example. Realize I had some writing on here. I'll erase it real quick. And then we'll go to these. We're right here. All right, so at the top it says, vectors continued. Find the magnitude and direction of RT, the vector RT, which would have the initial point R. So this is your x1, y1. And T is where it ends or terminates. That's your x2, y2. Draw a right triangle with RT as the hypotenuse. So they drew this out. Find the change in y and the change in x. So if you wanted to count, you can actually count up here. 1, 2, 3, 4, 5, and you went to the left. So this would be -5. I can do it with the numbers as well. So I can do 2 minus -3. Oh, this says change in y's first. 4 minus -2. I don't want to misread the... I just did the y's first. 4 minus -2. And the x's would be 2 and -3, so 2 minus -3. I just did the x ones first, didn't I? I sure did. Guess what I need to do? I got to turn those around. My apologies. I got tripped up there for a moment because I was thinking, oh, they put the x's, change in x's. I was thinking of doing the change in y's first. I need to reverse that, please. The y's are 4 and -2, but we got to start with y2. So it should be -2 minus 4. And the other one would be -3 minus 2. Okay, now what does that give us? The change in y is -6, and the change in x is -5, which is exactly what we do here if we counted it. Going down, 1, 2, 3, 4, 5, 6 would be my -6. Now, to find the magnitude of the vector, we will do the change in y, or x squared first. I'm going to go -5 quantity squared. Priscilla, can you close the door, please? Thank you very much. And the negative 6 is your change in your y, so that's going to get squared. Just some weird sounds out there. Okay, so here we go. I'm going to remind you that when you square a negative, you always get a positive. Okay, negative 5 times negative 5 is 25. Negative 6 times negative 6 is 36. When we add them, we get 61. So we're going to need to take the square root of 61. So grab our calc. Second, x squared, put in your 61. I think that's 7.8. About 7.8 because we rounded. All right, next we're going to find, I believe, the direction. Okay, so what they did was they took the negative 5, negative 6, and they plotted that. This is, again, left 1, 2, 3, 4, 5, and down 6. Show you what they did. So they repositioned the vector starting at the origin. It's still the same length. And this was the negative 5 and the negative 6. And this was you guys got 7.8 units. Now we're going to use trigonometry to find the vector's direction. We want to know this angle. So let's find theta. They already put it down for us, all right? But I want to show you how they got it, okay? Inverse tangent will get of change in y over change in x will give me the angle's direction. So if you look up here, tangent of theta would equal negative 6 over negative 5, just like we've been doing, opposite over adjacent. So we're going to actually need to do the inverse tangent. That's what this is. The theta will equal the inverse tangent of 6/5. Why didn't I put the negative signs down? Because this reduces to cancel out the negatives. You could put them in there and it won't hurt anything. Okay, but I just wrote 6/5 because a negative divided by a negative is positive. So then we grab our calculator and we hit second tangent, 6 divided by 5. And if you did negative 6 divided by negative 5, it won't change a thing. And we got the 50.2. That's where they got 50.2 degrees. Now, there's a couple ways to describe this direction of this vector. When repositioned, again, this is what they did, so that the initial points at the origin, ray RT, or vector RT, excuse me, not ray, lies in the third quadrant and forms a negative angle with a negative x-axis. To measure the angle R, the direction of vector RT is the angle it makes with the positive x-axis, which is angle R plus 180. See, this is 180, and then they added on 50.2. 180 plus 50.2 would give us 230.2 degrees. So therefore, RT has a magnitude of about 7.8, forgot magnitude, 7.8 units, and a direction of about 230.2 degrees. Now, I'm going to be honest with you. I'm not going to ask you to give me that measurement. I'm going to ask you to give me something off of east or west. So let's look at this again. If this is north and this is south, this is east, and this would be west. If I asked you to give me a different direction, please write or at the below here, 50.2 degrees. And now, how is this little angle opening? It's opening toward the south, coming from the west. So you can say it's 50.2 degrees to the south of west. South of west, S of W. And we'll go over several more of these so you hopefully understand how I'm describing it. This is what's going to be on a quiz or test. I'm probably not going to have any answers that would come out to this, the 230.2. So I'd prefer this way. All right, now find the magnitude and direction of FG. Did you guys, this isn't on your paper, is it? This ray. Okay, I'll see where it came from then. All right, so we're going to plot negative 1, 5, which would be up here, and that would be F. G at 3, negative 2 would be down here. And the arrow would be at where G is. So it's going to look like that. It says find the magnitude and direction. Okay, so here's what I'm going to do. Find the change in, or let's do the component form. I'm going to show you how to do everything on here. Component form, that's when you take your x1, y1, and your x2, y2, and subtract. We're going to do the x's first, 3 minus negative 1, and the y's second, negative 2 minus 5. The component form would be 4, negative 7. Okay. I'm now going to remind you that this is the change in the x is 4 and the change in the y is negative 7. And now I'm going to plot that. I'm going to show you where 4, negative 7 would be. I know it's not, you can't really plot it on here because negative 7, I'm just extending that, guys. So from 0, 0, the vector would slide to here. And that is just the vector moved to the origin, repositioned to the origin. Another way to have looked at this to get those values of 4 and negative 7 would have been to count over 4 and down 7. This thing is still got the same numbers. So if I say, what's this? It's 4, and this is negative 7. I want to know this angle right here. So I'm going to put a theta on it. So you can kind of see why I'm doing what I'm doing. All right. Now I'll show you how to get it whatever way you want. We need to find the magnitude. So magnitude, how you find the magnitude, that's going to equal the square root of the change in x squared plus the change in y squared, which we found out are 4 and negative 7. So we're going to do 4 squared plus negative 7 squared and take the square root. That's 16 plus 49, which gives us the square root of, what's that, 65? Yep, 65. And that's approximately 8 something, 8.1. Okay. And finally, I'm going to find that angle theta. And the tangent of theta is equal to opposite over adjacent, negative 7/4, or it's the change in y over the change in x. Okay, now the way to find the angle, okay, to find theta, you do inverse tangent of the change in y over the change in x. So here we've got a different, however which way looks for you, whatever way works for you, they're still going to be the same process. You still have to take the inverse tangent if you set it up this way. And that's negative 7/4. We need to type, I just wrote that goofy. Let me make that clearer. What it's going to look like on your calculator, second tan, negative 7 divided by 4. Now, the calculator is giving us a negative angle measure. And there's a lot of reasons I could explain that is what it is, but that is a little bit beyond the scope of this course. So we're going to talk about it as a positive angle. Or if you wrote down negative 60, was it 0.3? I'll explain how you could describe this angle. It could be all the way from here to here, which would actually be 360 minus 60.3. So one way to describe it is the one I'm doing right now, which is 299.7 degrees. Or, and here's what I prefer, 60.3, just make it positive, degrees to the, if you're going this way, this is the south. You're coming from the what? What would this line be? East. So you're 60.3 degrees to the south of east. South of east. Okay, and our, this isn't, I'm waiting till we get to the worksheet. All right, so let's go to the packet now. Isn't this the last example? All right. I'm going to try to get a blank one here. Okay, so in your packets, we've already talked about all of this stuff. So I'm just going to hit right to it. And you're right here, right? It says component form of vector. Here we go. Number one, find the component form of each vector, then find the magnitude of each vector. All right, so remembering that at the beginning, ooh, I don't want to move things around here. That the initial point is C here, and the end point or terminal point is E. This would be your x1, y1, and this point would be your x2, y2. So to do component form, we subtract the x's, 4 minus 1, and we subtract the y's, 3 minus negative 1. That gives us 3, 4, which is the same as counting over 3 and up 4. The magnitude is the square root of 3 squared plus 4 squared, which is the square root of 25, and that gives us 5. Okay, number 2. You've got your start point where B is. So this time, your x1, y1 is up here on the left, and your x2, y2 is down here on the right. You can count as well. If I subtract the x's, I would do 3 minus negative 2, which is positive 1, 2, 3, 4, 5. If I subtract the y's, negative 3 minus 2 is negative 5, which is the same as counting down 1, 2, 3, 4, 5. The magnitude will be the square root of 5 squared plus negative 5 squared. Be careful and make sure you remember that when you square negative, you get a positive. So this is the square root of 25 plus 25, which is the square root of 50. And we're going to go ahead and use our calculator for that and give a decimal estimate. Although we did learn to simplify radicals, we could say it's 5 times the square root of 2, or 7.1. Right? That's it for that. We're on to the next. Give the magnitude and direction for a vector. Find its component form. I just remembered something, and that is that I did not do the last page in the ISN, did I? No, we didn't do that final page, which is what the next questions are about. It says vectors continued, or the last page of the vector thing. More vectors. Forget what I saved earlier today. Let's see. I don't think this is the ISN. Thing was, I made a new ISN today for the whole thing, and then somehow it got deleted, or I deleted it. Well, here it is. Okay, so let's finish up the ISN page so we know what's going on in this next thing. Vectors can also be added or subtracted algebraically. All you do is take the corresponding components and add or subtract them. So if you want to add these two vectors, what you do is you take -3 plus 4, add the x parts, and you add the y parts, 2 plus 0. And that would give you 1, 2. That's all there is to it. Add the corresponding pieces. To find the component form, give them the magnitude and direction. There's an example already filled out for you, and I'll show you why it is what it is. When you have a vector drawn in a quadrant and you have an angle given, the magnitude of the vector would be on the hypotenuse, if you will, if you draw a perpendicular line down to the x-axis. This would be x, and the change in your x, and this would be the, oh, I just said it in the wrong place, hello. This is your change in your y's, I got distracted. And this is the change in your x, of course, horizontally. So if you were going to find x, you'd use the cosine, because it's adjacent and hypotenuse. Cosine of 32 is x over 19. You would multiply 19 times the cosine of 32. That's what this is saying right here. Vector magnitude times cosine theta will give you the x part, vector magnitude times the sine of theta. I'm not even going to bother you trying to look at that. I just want you to go here and say, all right, how could I figure out the x and the y? Here's how you can do it. You draw a perpendicular from the x-axis to the tip of your arrow. You put, say, horizontally, that would be x, vertically would be y. I'm going to write an equation to find x involving the hypotenuse, if you will. So this would be my adjacent leg to the angle. Y would be the opposite. And 8 would be the hypotenuse. So here's why it is what it is. You take and say, all right, I want to find x. It's adjacent to 35, and I know the hypotenuse. Adjacent and hypotenuse is my cosine. So I say cosine of 35 equals x over 8. I calculate 8 times the cosine of 35 to get my x component. So I go 8 cosine 35. That gives me 6.6. Now, we are in quadrant 4, so 6.6 would be positive. The x value would be positive. But the y value, first let's find it. To find y, it's opposite the 35, and you have hypotenuse. That's why we do the sine of 35 equals y over 8. We then cross multiply, do 8 sine 35 to get your y value. 8 sine 35 gives me, if I get it to type, 4.6. Now, that's negative because we're in the fourth quadrant, so it'd be negative 4.6. The calculator's not going to tell you the right plus or minus sign. All right, you're going to get 4.6. You have to realize you're in quadrant 4, so y is negative in that quadrant. It's like if you were plotting a point. Okay, I think that there's one more thing on the ISN, and that's what's going to happen if you're given the we want to find the magnitude right here. I'm going to find that. That's Pythagorean theorem. So we just say magnitude is equal to the square root of. Your formula is the change in x squared plus the change in y squared. They are already provided. The change in x is 42. The change in y is 30. So we're going to be doing the square root of 42 squared plus 30 squared. So let's find out what 42 squared plus 30 squared is. Okay, 2,664. We need to take the square root of 2,664, which is about, I don't know. I need to put it in my calculator. 2,664 square root. All right, then I get 51.6, and I need to label that approximately 51.6 miles per hour. Does it ask us to find the angle as well? No? Okay, then we're good. And that's, oh, I'm sorry, it does. The next part does. I couldn't pull, I should have turned the page and I would have found I had more here. See, our answer that we just got right here was 51.6 miles an hour. All right, and we did it by doing that and blah, blah, blah. Okay, directions can be measured in several ways. Many times the measure is often asked off the positive x-axis. Other times it's given as degrees off of east or west. Find the measure of the angle shown at the right. All right, so up here, this is my change in y. This is my change in x horizontally. So I'm going to find that angle by saying change in y is 30. Change in x is 42. Okay, so I'm plugging those in here, which means I'm going to type second tangent of 30 divided by 42. And that's 35.5 degrees. So we got 35.5 degrees. So this angle would be described as 35.5 degrees to the north of west. Okay, it's opening. So that means that it's that many degrees to the north measured off of west. That was my theta. Okay, you've got, go back to the packet where this stuff is right now. And this is why I stopped and went back there, because it's asking us for that kind of stuff. This is the example, I believe, that we just did, one of them. We want to find, given this magnitude and the angle, we're going to find the component form. So this is going to be my x, and the vertical number is going to be my y. Just like plotting points. So, adjacent over hypotenuse, cosine of 32 is equal to x over 19. You will calculate 19 cosine 32 and get x. 19 cosine of 32. I got 16.1. We are in quadrant 1, so that's positive. To get the y component, opposite over hypotenuse would tell me to use the sine of 32 equals y over 19. So we'll calculate 19 sine 32. We got 10.1, and we are in quadrant 1, so that is, don't have to worry about the sign of it, positive or negative. Number 4, though, is in quadrant 3. We do have to worry about the sign. Y is vertical, x is horizontal. To find the x value, adjacent hypotenuse, we do cosine. And the sine will find us the y value. So that's how it is every time. 26 cosine 50 is 16.7, and it's negative because we're in quadrant 3. X's are negative over here. This section is negative, negative. This section is positive, negative. This section is positive, positive. This section is negative, positive. I mean, if you don't remember that, we need to know it. It looks like a little face. All right, now the next one's going to be negative as well. I'm just going to write it down and then go ahead and calculate 26 sine 50. I got 19.9, and it would have been negative 19.9. All right, next one. Given the magnitude and direction for a vector, find its component form. Same thing. Drop, go from, yeah, we're good. Go from the arrow tip up to the x-axis. This is your x, this is your y. Still going to be the same thing. Cosine 35 equals x over 8. And sine 35 equals y over 8. This time we're in quadrant 4. So I know you guys know you're going to type 8 cosine 35, 8 sine 35. One is for x, the other is for y. Okay, so when I do 8 cosine 35, I found out y, 6.55, so I'll round that to 6.6. Is x positive here or negative? Yeah, if you're going to the right, it's positive, so that one's okay. But the y part's going to be down, so it's going to be negative. But the answer won't, calculator's not going to tell you that, though. 8, what's I doing? Sine 35. And that's 4.6. So it's negative 4.6. So you've got to know that you have to decide the sign. You have to know what quadrant you're in. Okay, so then number 9 says a plane. I don't know why it says N. A plane is traveling along a path due east at a rate of 350 miles an hour. This would be your due east. And the wind's blowing due north at 45 miles an hour. What is the magnitude of the resultant velocity of the plane? Okay, so the wind has an effect on your speed. So we're going to be doing the square root of 45 squared plus 350 squared. It doesn't really matter what order you type those. This is going to be a big number. So I got, 124,525. Is that right? Okay, remember that correctly, and I have to take the square root of that. You can pop your answer in, kind of save a little time typing. You should be getting 352.9. And that's going to be in miles per hour. Okay, the next one on number 6, I know you had to flip your page. We're going to have to give an angle blank blank, and we're going to be finding this angle, and we're going to be finding the magnitude, m. Okay, so you could use your Pythagorean theorem. You could say m squared equals 3 squared plus 4 squared, or you could just say, well, m is the square root of 3 squared plus 4 squared. I don't care which way you start it, as long as you get the square root of 25, which is 5. All right, so the magnitude is 5 meters per second. That's what the MS stands for. I need to find the angle, so I say opposite over adjacent. That would be the tangent of theta, the angle. I'm just using a theta instead of an x. 4 over 3. So you're going to type inverse tangent, or second tan, of 4/3. Okay, 53.1 degrees. Now, that's 53.1 degrees, and how is it opening? Towards the... Okay, it's opening that way, guys, towards the north from the east. So it's 53.1 degrees north of east. Okay, we're going to always end with east or west. Okay, so this one, see how they drew it? What's wrong or what's different about what I did? Don't go to the y-axis, all right? Don't. It needs to go to the x-axis. So we can fix this very easily by drawing a perpendicular up there, and then the 7 would go here, and the 16 would go here, and we'll be all set. because we actually want to know the angle that goes right there. All right, so we're going to say our magnitude is the square root of 7 squared plus 16 squared. And then we'll do inverse tangent for the angle, and we'll do 16 over 7. Those are the calculations you need. And I realize we are out of time. We will continue with more vectors tomorrow, but do try some of the problems.